The 2022 C&I Rooftop Solar Project of the Year, as voted by the readers of Solar Builder, is the University of California Riverside project in Riverside, California. Stronghold Engineering was hired by the university to design, construct, and install PV systems on two large targeted campus buildings, totaling 474 kilowatts. The job involved maintaining the look of the building, maximizing power generation, and getting creative with additional roof work. Here to tell us how they did it is Kevin Getz, Solar Manager for Stronghold Engineering. Hey, Kevin, congrats on winning the 2022 C&I's Rooftop Project of the Year award.
Thank you very much.
So the University of California Riverside wanted to maximize power generation on the roof, but they also wanted to preserve the existing architectural characteristics and minimize the overall impact on the building. What do those last two notes in particular entail?
Yeah, they're very proud of that building. It's a very nice building. It's a newer gym. And well, I'm going to say one thing first. Working with the staff there at UCR was amazing. You know, it's from the inspectors to everybody else we had to work there in the facilities was absolutely amazing. And so we were communicating quite regularly all the way from the very beginning on. Being a university, you know, you don't just have like free access. You're just like, hey, I'm just going to get the crane in there today and, you know, hoist it up. But, you know, they were really good about all that. So getting back to your question, yeah, they were very concerned about the aesthetics of it. You know, they really didn't want to see it protruding above the parapet walls, which really isn't much of a parapet wall. It's like anywhere from a couple inches to maybe 1.5 feet. So literally it's kind of in a little, I don't want to say a big valley, but it's a little bit of a valley. And if you were driving and if it was sticking up, you would see it. And they really didn't want anything like that. And also, you know, we wanted to maximize the output. And so that's kind of where we came up with the east-west.
I was going to ask about that. You went with the east-west configuration, and it seems like that does achieve both things. Are those reasons why you would go east-west?
What we do is when we go in design, we kind of do several different designs. So we, you know, started off with the 180 just for base comparison. It was good, but then we started looking at the east-west. I used the helioscope, and they have the east-west configuration in there, so it's pretty easy to do it. You know, you'd be stupid not to. So it just came up to where, hey, you know what? We got 50 more modules on the roof, 50 more modules with this, and that came out to about 12,000 more kilowatt hours a year. What really helped us in this one, there's a big curtain wall around all the AC units up there, and that thing's like probably 15 feet high. If you look at the northwest side, the back part of the array up there, it would get a lot of shading because it's so tall. It's gonna, the shade's gonna hit directly on that, because it's south facing. So when you go east to west, it kind of mitigates that. You get a little bit of shading, but you still got the west and you got the east strong.
The roof itself, it sounds like you encountered some issues up there. What was the roof condition like, and what did you need to do to remedy some of that?
Oh yeah, that roof, there was some tough stuff on that. It's a good thing we videoed that thing too, because going into design, going back on, I recommend to video every job walk. Just always do it, because you know what, pictures are great, but video, you can see some, So one of the problems we had is the lifeline. You can't see it in the pictures, but there's a stainless steel lifeline with posts all around there, and it's inconsistent how far it is from the edge. That really inhibited our placement on the modules, and we had to relocate some of these posts, and they're really hard to relocate. They have to set on a beam, and they have to be like welded on there. And then when we did that, the engineers came back and said, hey, there's torsion on it if someone falls, so you have to go underneath and put diagonal bracing on the I-beams. And that was a lot of standby time too. And the other thing is, on that one roof, even during the job walk, they mentioned that the roof probably wasn't up to par for the PV. So the structural engineer looked at the whole roof, and sure enough, he identified one area that needed to have some work on it. So we ended up sistering on a girder that had to be welded on to beef it up. So we did all that from underneath, and thank God most of that roof is open beam in there, so it was kind of minimal impact. But we did have to do some drywall repair and stuff, but not too bad.
And when you say we, is that the type of thing where you partner with someone else where that's their bread and butter, or is that something you guys actually take on?
We take on most of the work. If you look at our website, we have a lot of different divisions in our company, not just electrical, but we have like the civil division. We have yellow wiring, we have carpenters, we have masons. So we pretty much take a lot of it on.
And having all those divisions, is that part of the philosophy at Stronghold to maybe look at any type of building a roof, like knowing that you might be able to accommodate or come up with solutions that just a solar installer that's mainly focused in C&I won't be able to do on their own?
Yeah. Well, see, solar is like our renewable division isn't the biggest part of our company. We're definitely growing in that. I'm into my 14th year now. We do all kinds of other work, military and federal and all that stuff. But what's really great about the atmosphere is that we all team together. So we get on the job, we pretty much got it covered. Trenching, not a problem. We got guys get out there, do that, or masonry work to do our pads for our gear. And it goes seamlessly. So everybody's like basically on the same team. So it works very well.
Was there anything tricky about the layout of the system, in terms of the wiring or the electrical balance of the system? Just anything else that stands out that it was kind of tricky in how you had to configure it?
We went with SolarEdge, and at the time they didn't have an optimizer that we could get that can get 2 to 1, because if you take 2 modules and you wire both those, you're over the 80-volt rapid shutdown limit. So basically every module has an optimizer.
The university was interested in something like that in terms of really getting granular with monitoring or displaying it somewhere and kind of making that part of the messaging of the university.
Yeah, they all like that. And then a lot of them, I was surprised at how many of them wanted to access the monitoring. So we had to set them up with a bunch of accounts, and they do monitor it. They are looking at it all the time. Originally, it was going to be the inverters were going to be throughout the arrays, you've seen them before, kind of at an angle on a rack. And, we really like to design our systems with O&M in mind, looking forward to that, because we do a lot of O&M on the projects that we put in. And, over the years, we really refined it and things, I think good O&M starts during design.
Do you have an example of like how that plays into your design then?
Well, the inverters, we mounted all the equipment centrally, and it's not by the array. It's actually, there's some big ducting that's taken up some space on the roof. And so we built a rack right up against that, because it's not open roof space right there. But so we built the rack there, and we have all 3 inverters on that, the 100 kW inverters on that with gutter underneath it, and our DAS and our solar sub panel is mounted right next to us. So everything's central. So if I got to go up on that roof, and by the way, it's really close to the roof access, within 20 feet. You come up to the roof, and then there's since it's a TPO roof, it has mats on it that you're supposed to walk on. So we're not going in walking on the areas that we shouldn't be. And so we get up there, and then there it is. The inverter's right there. I need to do anything, I can go right over to my sub panel, open it up, and turn the breakers off that I'm working in that. I don't have to go hunt for it. Everything is right there. It's also out of the sun. It's actually facing north, and it has that duct kind of behind it. So it's kind of shielded from the back. That was a little bit of work, because the engineers came back and said sleepers aren't good enough how we had it designed and drawn out. And typically that is good enough, but it's a gym, it's a school, they're going to be extra cautious. So we had to do some structural work underneath that to attach it. We had to put some stanchions on it, and then, with the unistrut, but it sure looks nice.
I got to just say that I was happy that our readers voted for this project in the field. C&I section is always the most heated in terms of a number of votes, and the projects that are kind of like similar in a certain way. And a lot of them can go toward projects that maybe pull the heartstrings in a certain way, but at Solar Builder, we try to be a little bit more technical and really focused on the install side. And I liked that this one had some tricky nuances in terms of the actual design and installation that you guys had to overcome. And I'm glad that was kind of the story that won the day with the audience this time. So I just wanted to say, just congrats again on winning this year's award for Rooftop Project of the Year.
All right, thank you very much.